A Mo programmer, that is, a programmer using our new language Mo, wants to write arithmetic like this, 2 plus 1. But our interpreter needs a representation of that 2 plus 1 as an exp data type. This 2 plus 1 we would call concrete syntax for Mo, while this plus E representation is the abstract syntax of Mo programs that our interpreter deals with. So how do we bridge this gap between what a Mo programmer wants and what our interpreter wants? We can't have Mo programmers write just 2 plus 1 in Shplait because that is just a Shplait expression that produces 3. But what we can do is have them write 2 plus 1 but put quotes around it. And then what we get in Shplait is a syntax object that records the fact that there is a 2 and a plus and a 1 inside and lets us give meaning to those ourselves as a Mo program instead of a Shplait program. The process of going from these syntax object representations of concrete syntax into abstract syntax, that is the job of a parse function. So now we want to write a parse function that takes syntax objects and turns them into exp representations. We can summarize the concrete syntax like this. We want syntax objects of each of these 3 shapes, just a number with a plus in the middle or with a times in the middle. And getting that into X data type is again the job of a parse function. There's one more detail to consider though. Often when you go from concrete syntax to abstract syntax, you're simplifying away some aspects of the concrete syntax. And in this case, for Mo, we will also want parenthesized expressions, such as if you want to add 2 numbers before you multiply them to something else instead of the other way around, you'll need to put parentheses around the plus part. We don't need parentheses in our X representation because the nesting of plus E and multi there's already parentheses built in. It's these parentheses, if you will. But our parser will need to take care of that. Again, these kinds of simplifications are common, and that's why it's standard to separate your interpreters into a parse and then an interp function. So how do we do that? We need to use some Shplait facility that lets us look inside of syntax objects, so that when our parse function gets a syntax object, it can look inside to produce a suitable exp. Okay. The way that we look inside in Shplait is using a pattern. This looks just like a syntax object construction, but when it appears inside of match, as one of the cases of a match, it means match a syntax object that has this shape. So S will match whenever it has an asterisk with anything to the left and anything to the right. And that anything to the left can be an expression as long as parse will treat it as an expression. So parse does really 2 jobs, recognizes valid matches to the shapes of syntax objects that we allow, and also turns them into exp things. There's one catch though. If we, the first case of our syntax object patterns has just a number inside, if we try to use match on a pattern here that just says, well, match any n, that will match anything, so we haven't made any progress here, and we haven't made sure that we recognize only numbers. So instead of using match directly, we'll need 2 layers. First, we'll need to check whether this syntax object is just a number inside, and the built-in function syntax is number will do that for us. And then if it's not a number, it must be one of these interesting cases that we can match on, and so we'll go to match in that case. There's going to be one more detail about how we set up this match. Suppose we have an expression 1 plus 3 times 4. Is that 1 plus 3 first and then by 4, or 3 times 4 first and then adding 1? Well, of course, we want the usual precedence for times. If we match on a times expression, though, 1 plus 3 times 4, well, then the left matches 1 plus 3 and the right matches 4, and that would be bad. On the other hand, if we had tried matching plus first, then 1 matches on the left and 3 times 4 on the right, and that is what we want. So it turns out that in this style of writing parsers with match, we can handle precedence the right way by just ordering our match clauses the right way. First, try to match plus because it has the weaker precedence, and then for things that are stronger, like times, try them later. This will do the right thing when we have parentheses in our expression. So in this case, I have 1 plus 3 in parentheses. I do want to do 1 plus 3 first. That's going to work out the right way. So suppose I try to match 1 plus 3 times 4 to plus and times terms, ordered like we said in this way. In this case, it turns out only the times can match, which I'm illustrating by showing the result here. And the reason is this plus here, it can match anything on the right, But 3 close paren times 4, that would be broken by itself, right? You can't have a close paren all by itself. In fact, parentheses here form a single thing from the perspective of the sequence of terms on the outside. So the plus doesn't match, only the times match is where left ends up matching parenthesized 1 plus 3, and right ends up matching 4. So this ordering of clauses is going to do the right thing when we have parentheses as well.